Awesome. Okay. So this morning we're going to talk about modules, and this is something that I know that in my check-ins or evals with some students in the last few projects, I've mentioned this a few times when we've talked about similar behavior in different classes. And so I think that this comes in handy, especially with this current project that y'all are working on. So some of you may have found a lot of repetition in your classes that you've made so far, or the methods, I should say, that you've made so far for the stat tracker that you're doing in football. And this is definitely something that might come in handy with that project. I would expect some of y'all to most likely implement. And today we're going to go over kind of like the basics of what a module is and one instance of like how you could use them. There's a few different ways that you can use modules, excuse me. But today we're going to specifically talk about one way being a mix-in. So we'll kind of get to defining that in a little bit, but for right now, I want y'all to take a look at these two questions. So I think I kind of gave you like a brief overview of what a module is. And this first one, what do you know about modules already? If little, what would you guess modules are all about? If you can't answer anything for that, just try and make a guess for that one. And then this second one, football, American football, and soccer both use a ball, but each has its own attributes. What behaviors might they share? So two different sports. What are some behaviors that happen in both of those sports that are similar? And then go ahead and kind of list those out. Y'all can do this on your own for right now. I'll give you about 2 minutes to do this. Sorry, hold on. Okay, I don't think I'm sharing sound on this right now, so apologize if you didn't hear that timer go off. But let's go ahead, let's jump into these two questions. So I'll take volunteers for this. What do you know about modules already? And if very little, what might you guess they're about? You all can just raise your hands. Todd.
Yeah, they act like a combination of a helper method and a class all in one. That's what I would say of what I know.
They act like a combination of a helper method in a class. Okay, so can you expand a little bit more on that? And it's okay if you can't, but what do you mean by they act like a helper method in a class?
Well, whereas different methods will use the same, I don't know, technical aspects, like you'll have similarities in methods, and you have a helper method which you can use in different methods, right?
Yeah.
And that appears to be the same with within within a module, which is in a different sheet, a different location, which is kind of like a class. But that's all I kind of know now.
Yeah, I kind of like that. So you said kind of like a class. Modules aren't classes, but they look like classes. So I'll go along with that for now. And you said as helper methods are to methods, modules are to classes. Is that kind of okay, that similarity there?
Yes, now that you put it that way, yeah, yeah.
Okay. Yeah, so it's able to help out two different classes, specifically with mixins, using modules as mixins. Hope, I think I saw your hand raised.
Well, there's a really good example of a module that we've been using already,
What is it?
enumerables.
Yeah. Yeah, awesome. Do you know anything about that? Can you expand a little bit more on that, Hope?
Well, I'll give this description. An enumerable is something we can use in nearly any class, depending on what its function is, like which one you're calling and how you want it to work. So my definition for a module is just a class-like object type that can share functionality between classes.
Yeah, cool. I like that. And I think I really like that you brought up this idea of like, we've actually been using modules and we don't really know it. And you use that enumerable as one example. And yeah, that enumerable is actually a module. If y'all think about like in your classes that you're creating, your Ruby classes that you create, in any of your classes, you're able to use any Ruby enumerables. Where does that come from? That comes from access to a module, which actually is higher up in the lookup chain. I think it's from an array object in like the documentation for an array object. It includes the module for enumerables. And so any type of array object has access then to these enumerable methods that we've been using. Since it's so much higher up in the lookup chain, you can also use them outside of classes too. Like even if you jumped into a pry session, you can use enumerables. It's almost like it's just like part of Ruby, right? But actually higher up those modules for enumerables, or I think there's like a comparable where like less than or equal to, that type of stuff where you can use, like it feels like you can use anywhere, that has been included in different objects higher up in that lookup chain. Great example. Thanks, Hope. Anyone else things to add on modules? All right, I'm gonna stop my share really quick. I want to share, we'll get to that second question in a second. When I try to attach my whiteboard, it only lets me use half of my whiteboard when I'm attached to a monitor. So I'm just gonna share my monitor, or sorry, my desktop right now. Okay. Okay, so the second question was, football and soccer both use a ball, but each has its own attributes. What behaviors might they share? Let me go ahead and share my whiteboard. Can you all see just a whiteboard right now? That's all you can see? Cool. All right. Ah, darn, it's still going to that other one. Okay, hold on. Okay, you can still see my whiteboard, correct? Perfect, awesome. Okay, so let's go ahead. I'm gonna let you all unmute yourselves for this, just so that I don't have to manage whiteboard and participants tab all at once. So go ahead and unmute yourself, and I want you to list out some of those behaviors. Just go ahead and shout out some behaviors that are similar between football and soccer.
Kickoffs.
Pass.
Inflatable.
What was that last one?
They're inflatable.
Inflatable. Okay, the
Yes.
balls are inflatable.
Scoring goals.
Yeah, goals.
They both adhere to the physics of Earth.
They have players.
You're
And
physics.
Teams.
so players, what Hope said, but the players have positions.
Yep.
There's penalties.
Penalties. Yeah, that's what I was gonna say. Penalties.
Penalties.
There are results.
Results. Yep. I think it kind of goes with scoring or like a winning. I guess we could say that too. Results, like a winning team.
Either pass from player to player or player to space. Oh,
Player to space. Yeah. Are you saying like passing in front of someone?
yeah, or like punting into space. I don't know about gridiron
Gotcha.
football.
I see.
Yeah.
You can tackle.
Punting, I heard. Tackle. Yeah, you can tackle in both. Cool. All right, we'll pause there. I think we got kind of we got a lot of things here, and I think some of this we could kind of break out to being like, okay, some of this is more like objects that they have in common. Like I would think about what was it? Players. This like players right here. That this. Oh wow. Let's just erase it. That players would be more of a like object that we could say they both have player objects. Out of all of this here, I'm kind of going through here and I'm thinking like, what are behaviors that they have? So when we talk about behaviors, what are actions or, yeah, I guess I'll stick with that. Behaviors that each of them have. I think like kickoff, that's kind of a behavior. Passing, that's a behavior. Inflatable, we could say like inflate the ball before playing, right? Or checking if everything is inflated to the right pressure is always important.
Deflated.
Or deflated in some cases. Okay, scoring. Yeah, I'd say that's also behavior. Goals, maybe they were like keeping track of goals. That could be considered a behavior. I think this like goals and scoring could kind of go hand in hand, and we could kind of group that together into scoring, just one of them, a score method or something like that. Adhere to physics. Yes, I agree. That is also a behavior. I'm unsure how we would put that into code, but I'll leave it there for the sake of, I like it. 2 teams, maybe like setting teams. Yeah, positions. I think this might kind of go with players, so I'm going to take this off, positions. Being like that would probably be an attribute of players. Penalties, we could hand out penalties. Results, maybe we have something that gives us kind of the final score. And punting, another action. Tackle, another action. Cool. All right, so we have a bunch of behaviors here, and I think we can look at all of them as, why is it doing that? That's weird. Okay, well, pretend that they're together. I don't know what's going on right now. We can kind of think of all of these somehow to be some type of behavior. So let's try this one more time. Nope, it's not going to let me. Okay, I'm just going to have to make this big. Okay, so let's say over here we have football. Kind of thinking this as like a Venn diagram in a way. And we have soccer. And if we think about those Venn diagrams, we have some circle over here for soccer. We have some circle over here for football. And those are behaviors that are included in both of them. We could have different things over here that are only for soccer, only thing for football over here. But in the middle here, this is behavior that both of them share. So when we talk about modules, we're talking about that behavior that classes would share, and specifically modules for what we call mix-in. There's different uses for modules. In Mod 1 right now, we're only really going to be focusing on the use of modules for mix-ins. And when we talk about mix-ins, let's go put this up here. Mix-ins, we're talking about using modules to store shared behavior amongst classes. So if these were all methods, let's say we had all of these kind of actions, this behavior here, these were all different methods that we had. Up until now, what we probably would have done is we would have taken all of these methods and we would have put them in each of these classes. Let's say like this is the soccer class, this is the football class. We would have had all of these methods in the soccer class. We also would have had all of these methods in the football class. Thinking about kind of like principles of OOP and thinking about Ruby conventions in general, what principle would having all of these methods, the same methods in both the soccer class and the football class, what principle does that break?
Dry.
Dry, yeah. So don't repeat yourself, right? That's what dry stands for. So we don't want to have code that is repetitive. If we have it in multiple classes that is doing the same exact thing, then I'd say that's pretty repetitive code. So in order to kind of mitigate that behavior being the same in both classes and mitigate the problem of having repetition in both classes, that's where these module mix-ins come in. And the idea for that is that we have a module that I think a lot of people said it looks like a class. It's not a class, but it looks like a class. And what a module does is it stores, let me change this color. It stores behavior only. So everything that's in the middle here, we could say that all of this would be stored in a module. All of these methods here. In order to get access to these modules, there's a little bit more you have to do within the classes that you want to have access to those modules. And really all it is, and we'll go through kind of what exactly you need to do in order to include it in a Ruby class, is you need to just say in this class, hey, include, and then we could call whatever we call this module. Let's say we called it sport things, sport actions. Sure, we'll say like include those sport things. And I should have made this, it would be capital there, camel case. And same thing over here. Hey, include sport things. This is just kind of like a silly example right now. But with this like single line in here, as well as like requiring the file where that module is, then these classes still have access to those methods as if those methods were still in that class. So you can also imagine that modules, although we're talking about mix-ins right now and like using a module for shared behavior, modules are also great for organizing your code. And I think we talked a little bit in your project kickoff, Mike had mentioned that we don't want these classes to get very long. And so modules can also be a great way of kind of taking out methods that you have and putting them into a module so that that class still has access to those methods, but the methods are a little bit more specific to what that module is named, and it allows for that class to be a little bit slimmer. So that's also another way that you can use modules. But like I said, today we're mainly going to be looking at how to use them for this like shared behavior. Let me go ahead, let me put in my monitor again, and I want to jump over to my slides one more time. Will, did you have a question?
Yeah, so I think I may have missed the distinction between a mix-in and a module.
No, there's no difference. All I wanted to say was that a module can be used as what we call a mix-in. And so a mix-in is a module. It's just, there's different, when we talk about modules, and we'll, as we go kind of further throughout Turing, you'll talk about modules a little bit more in the realm of a module being useful for namespacing, which is not something that we cover in Mod 1. You'll cover it in Mod 2. So you can, if you want to take that and put that in the back of your head right now that like, okay, we can use modules later on for namespacing, which kind of goes along with this idea of organizing your code. And also goes along with this idea of like drying up your code as well. That's another reason why you could use modules. Another reason why you could use modules is for shared behavior. And when they're used for shared behavior, we call them mix-ins.
Okay, thank you.
Yeah, good question. Thanks for clarifying that. Curtis?
So like I've kind of tried to like implement a little of this in like our project, and I'm wondering, is it like if you have a module that you're tying to a specific class under normal circumstances, is it okay to like call instance variables in that module?
That's fine, as long as you have access to those instance variables in other classes that might be using that module.
Okay, thank you.
Joshua?
Is there a standard for how many methods you can have within a module, or is it essentially just limitless?
It's limitless, but I would still have it adhere to, I think what is it, 150 lines that we want in a class. We don't want it to go over 100 or 150. I'd have to look that up again. But I would have it still adhere to that length property that or convention that we're putting on classes.
Okay, thank you.
Yeah. Okay. If you have more questions on this picture that I just drew out, we can definitely pop back over here, but I want to pull up my slides again. And, oh yeah, still part of the introduction here. So this kind of covers most of the things that I just mentioned in that diagram there. So mix-ins or modules, right? We can think of them interchangeably, really. Mix-in is a module. Allow us to share behavior between classes. I'm just going to put this here as well, just so that you can have it written. Cool. And actually, I don't like grouping this together because some, I'll do it. Okay, thinking to myself. All right, so yes, mix-in modules allow us to share behavior between classes. Ruby implements mix-ins with modules. So in order to get this shared behavior within one place, we use modules for that. Since modules, we can include multiple modules in classes, and different classes can include that same module. So there's really no limit to how many modules you can include. We'll talk a little bit later this week on inheritance. I think modules and inheritance are confusing topics sometimes. I think in inheritance especially. And I think a lot of times the behavior that someone's seeking when they use inheritance could be satisfied with a module instead. And I mainly say that because I know there's some people that have brought up that idea of inheritance already and trying to implement that into projects. And I think maybe if you have questions on inheritance right now, hold off until that inheritance lesson. Right now, we'll just focus on modules, but know that inheritance is a little bit trickier, and it limits a little bit more as to what types of methods you can pull into a class, or how much you can pull into a class, I should say, because you can only inherit one thing, whereas you can pull in different modules, as many modules as you want into one class. So there's a little bit more limitations on inheritance when it comes to like the hierarchy of where these methods are found. So next one here, mix-ins modules, they look like classes, but they only hold methods. We talked about that just briefly already of like, okay, they look like a class, they're gonna have their own folder, or sorry, file, like a class does for our case. And the difference between classes and modules, I would say, is right here. So mix-ins, or these modules, they only store behavior. So when we were doing our warm-up, I listed out like, what are the behaviors that both football and soccer have? And those behaviors could be stored in a module. They wouldn't store state. What do I mean by modules are not storing state? When we talk about state, what are we referring to? Jake?
They're attributes.
Yeah, so this is not like an object. I can't call like module.new or like whatever I call the module sportthings.new. It's not an object itself. It truly is just a container for methods. So different from a class because it stores behavior, it stores methods that allow your classes to have behavior, but it does not store state. So they are not objects themselves. Any questions so far in this like kind of like high overview of what modules are? Taylor.
I have two questions, and maybe we haven't got there yet, but
Okay.
do you put module files within like the same lib folder, or do you create a separate folder for that?
That is, I would say for now in mod 1, put it in the same lib folder. As you get further in your tree, like where all of your files are, is getting bigger and bigger, you might have a separate folder just for modules. And it's really, that's totally fine. The only thing is you just have to make sure that when you're requiring your module in the class that you want to include it in, that you give it the correct path to get there.
I see. And do you write tests for modules the same way you would for a class?
Good question. So with modules, since they're not an object, you can't say like, hey, does this module exist? Because it's not something that you can instantiate, right? Like it's not something that has state. It just holds that behavior. So let's say I have a test for football and I have a test for my soccer class. I would want to test in both of those tests, for football test and soccer test, that I have that behavior that I'm expecting the module to give me.
I see. That makes sense.
Cool. And we'll get to that in a little bit too, a little bit later.
Cool. Thank you.
Yeah. Will, did you? I saw that you unmuted yourself. Did you have a question?
Sorry, I didn't mean to unmute myself.
Oh, you're fine. Okay. Any other questions right now? Garrett.
Sorry, I came a little late, and if you can't hear me, it's fine. I can just kind of mute myself for the rest of the class. But I guess I'm curious, like, what, and you might have covered this earlier, like, what is the purpose of using a mixer module versus just having the class? Like, you can just have the methods you create in the module or the mixin like in the class. So what's the purpose of taking them out?
Yeah. So the reason why we would have a module, I'd say there's a few different reasons. The main one that we're focusing on today is for the purpose of shared behavior in another class. So if you have, our example that we had before was football and soccer, both of those sports have similar behavior. And so if we had methods to be able to show that similar behavior, we could put them in a module so both classes didn't need to write those methods, but we could have them stored in a similar area where both could reach it. Cool. All right. And one last question, and I'll take whoever's hand pops up first. What song would you like to play during this next poem? No one's hands. There we go. Great, George.
Well, it's not gonna, I was gonna say it's dealer's choice because apparently we are real undecisive. So maybe anything, I don't know.
I can come up with something. I just wanted to make it
like
a little bit dynamic for y'all.
Dive. I mean, I like all of your music that you've chosen.
Okay,
So,
great. We'll play some more Lake Street Dive.
Yeah, cool.
Cool. All right, y'all, let's go ahead and come back at, what is it right now? 28. Let's go ahead and come back. Let's do 34.
Thank you, 34. Also, Meg, you aren't sharing your audio.
Okay. Tell me if you can hear this. No?
Yes, we can.
Okay, cool. Okay, so for this example that I have here is the code that we're working with. This was actually, I took this out from Let me go ahead and pull this up real quick. In the Mod 1 lessons for modules, there is a link to this. And so this is kind of what I decided to use for this. This is someone updated this lesson with this one. So I have not used it before, but it looks like it has been used in the past. So I'll go ahead, I'll drop this in your channel. If you all want to clone it down, you're welcome to, but I'm gonna walk through it just as an example. And then I'll send out another repo to all of you all for that individual practice. So here's the one that I'm using right now. And again, you don't have to clone it down, but if you want to, you can. So what we're working with here, we have two, this is not how it came, hold on. Let me delete this. Okay, so if you clone it down, all that's in here is two classes. So you have a photo class, you also have a status update class. And so just kind of looking through the code that we have here, let me go ahead and make this bigger just so y'all can kind of see what we're working with. We have a photo class, status update class. They both get initialized. They both have some state in them, some attributes there. And they both have this display, which is kind of dependent on what they got initialized with. And I guess kind of like the main functionality that we're working with here is someone's able to create a photo. Like if, let's think of like social media in some way, right? Like let's say someone adds a photo and then other people or yourself can add comments to it. You can also, let's say as that user, you could also delete comments from it. Same thing with a status. So if you changed your status, someone could add a comment, you could add a comment, you also could delete comments. So that's the main functionality that we're working with here. And then there's like this display to see what that photo looks like or to see what that status looks like. So very similar classes. And you can see then down here, there are nearly identical methods in both of them. So they both are going to add comments. They both have the ability to remove comments. And let's go ahead and run it just so we can see kind of how this next comment ID works and what the purpose of it is. So I'm just going to jump into a Pry session for this. Cool. Okay, cool. And let's start with this status update. So let me get rid of these two for right now. So for a status update, in order to actually run it in Pry, this doesn't have any tests right now, so just playing around with it in Pry. In order to run it in Pry, I need to require this file. So I'm first going to go ahead and require /status_update. Cool. So that is required now. Now I have access to this file and all the code in here. And let's go ahead and create a new status. So let's just say status equals status update dot new. We're learning modules. Cool. And if I take a look at status, you can see that's a status update object. You can see it got initialized with the body and comments. So let's play around with like what do all of these things do. So if I say status.display, I can see this is kind of the output that I see here. So status update, we're learning modules. And let's go ahead and add a comment to it. So let's say status.add comment. Maybe someone said, that's awesome. Great. And then we see added, that's awesome. We can see kind of this code here play out there. That's awesome for a total of 1 comment. And now if we take a look at status.display, we can see here's the body, we're learning modules, that's the status update body. And then we can see some comments there. We just have 1 right now, that's awesome. And let's go ahead and add 1 more. Have fun. And then if we take a look at the display, we can see it kind of increments there. So we can see all these comments coming onto our display, or sorry, our status update. And We also have this remove comment, and looks like it takes an ID of this number that's associated with the comment. So I could say status.remove comment, and let's say I didn't want to see this have fun on there. I want to remove that comment. Deleted comment with ID 2, comment count now at 1. And if I take a look at the display, now I only see that 1 comment there. So that's the functionality we're working with in this class. We can see this next comment ID where it's used. So it's used when we add a comment. It goes ahead and it increments the total comments up. So yeah, that's kind of what we're working with there. Same thing for the photo. I guess I can just do it right here. Let's go ahead and require /photo.rb. And I think I can copy. I'm going to copy this instantiated object from lesson plan. So photo equals this new photo. I'm passing it an address, also a comment that I wanted it to get started with. So if I look at photo, I can see this photo object. If I look at photo.display, I can see, here's the URL. I can also see the caption that I initiated it with, instantiated it with. And then same thing here, I can go ahead and we take a look at this photo class. We have add comment, remove comment. So I can go ahead and add comment and take a look at the display. I can see it up there. I can go ahead and add comment. I'm just adding things on here. Take a look at the display. We can see those added there. We can also remove them. Let's say we want to remove one. And then if we take a look at the display, we just have that second comment on there. So they both have this similar functionality of we have 2 different objects and people or users are able to comment and also remove those comments. Cool. So now that we have identified that we have this similar functionality, this would be a great time to use modules as a mix-in. So modules as a place to store shared behavior. So let's go through creating a module. And again, just kind of looking at these 2 classes. Let's go ahead and make this a little bigger. Looking at these 2 classes, what are the same? So these last 4 are identical on both sides, on both classes. So I think all 4 of these methods are methods that we can go ahead and pull into a module to be able to use between both of these classes. Let's go ahead and start with taking it out of, I'll take it out of the photo. Just make sure it works for one, and then we'll pull it into another. Okay, so with a module, I think someone had asked, I might have been Curtis, I forget right now, but where we put these modules, and it's totally up to you. I think right now in Mod 1, you can put it within your lib. Right now in this actual repo, we don't have any lib, so I'm just gonna go ahead and put it at the same level as my classes. So when it comes to naming convention for modules, what you'll notice is a lot of them have their ending in able, so like enumerable or comparable are a lot of like frequently, it's kind of like the convention that we can see a lot with modules. It's not a rule, but it just so happens that a lot of them are named that way. So you will see a lot of modules with that like able at the end. So let's say for this module, we'll call it commentable, since we're adding comments, removing comments, and both of them have this functionality. You can kind of see like we're naming it after the functionality of that behavior that's going to be in the module. So we'll go ahead and let's call this commentable. And in here, again, it looks like a class. It's not a class. Instead of the keyword class, we're going to use the keyword module. And then you can go ahead and name it. So we're going to name this commentable. And in this module, I'm just going to go ahead and paste those methods that I want my class to have access to. Again, I don't have like an initialize in here. This is not an object that I'm trying to instantiate. It's just storing methods that I want to be in my photo class. The one thing we're missing right now, and I guess kind of two things that we're missing, is although we have this module created, we pulled out the methods from photo, we put them into this module, we still haven't allowed the photo class to be able to read into this module. So in order to get this module to be included into this photo class, or I guess we could say the other way around, like have this module included in the photo class, we have to first require where that file is, and then we have to specify in our class that we're including that module. So up here, I'm going to go ahead and require /commentable. And then at the top, I think actually it doesn't matter if you have this before your auto reader or after it. Let me put it before it, and then I'll try it with it after it just to make sure it still works. But then the keywords that you need here, kind of like I wrote in on the whiteboard, is we need to just say include and then the name of the module. Include commentable. So key parts to including a module: 1, have a module, and then 2, require it and put this include statement. That's the only setup that you need. So now taking a look at, again, I just did this in the photo class. I haven't done it in the status update yet, but I just want to make sure it works for one of them first before I go ahead and include this module into my status update. So let's go ahead, let me jump out of Pry and get back into it. And I'm going to require that photo class. My photo class requires the commentable module, so I don't need to require that. My photo class is responsible for calling to require that, so I don't need to require that here. And then I had a photo object that I created. There's my photo object again. And display is still in this photo class, so I should, let's say, photo.display. I have access to that, I can see it. And then we pulled out this commenting ability, the commenting behavior, into a module. So photo.add comment, and this takes a string. And we can see added great for a total of 1 comment. So I was able to find that method just fine. It didn't give us any like no method errors. It found the method. It looks like it ran. And if we take a look at photo.display, we can see that it got stored into that state for that class, for that object, that photo object. Same thing with if I wanted to remove it. And I want to remove the comment 1. Now if I take a look at the display, I don't have any. So it looks like my functionality is working there. I think my module looks like it's all hooked up all right. Again, though, the module, the main purpose of it, when we're talking about it in respect to like using it for specifically for shared behavior, is that we're able to use this in multiple classes now. So now that I have it in a module, I can also go ahead and jump into this status update and look at like, oh, okay, well, actually all 4 of these are exactly what I have in the module. So if I just get rid of these 4 methods and go through my steps of including the module's already written, but I can go ahead and just grab this from up here, require commentable, and then same thing here. Let's go and put this afterwards just to see if this still works. Include commentable. All of that is saved. Let me jump out real quick and let's go ahead and try this with the status update. So require status update. And then go ahead and create this status object. If I take a look at status.display, we're getting a display back. If I take a look at status.add comment, Let's see if this works. We can see added, let's see if this works for comment, total of 1 comments. Take a look at the display and we can see it on there. So looks like doesn't matter if this include is before or after your adder readers, as long as it's somewhere in your status update, which I think it just makes sense to have it at the top, then it has access to those other methods. Okay, so I went through one example. I think this probably created some questions that y'all have. Who has questions right now? Will.
Just a quick question. Could you scroll to the top of the commentable again? I missed the
Yes.
oh, awesome. Thank you.
Garrett.
Yeah, just out of curiosity, why not put display in the module as well, since that's also in both?
Yeah, let's take a look at both of them. So here's my status update over here. Actually, let's do this. So status update over here.
Oh, I see. Okay, never mind. They're different.
Yeah, they're a little different. Yeah. So that's why I kept them separate for that. Taylor?
I guess I don't know if this is really a question, but it's interesting to me that you need to require modules at the top of the file if they're in the same directory, but you don't have to do that with classes, from my understanding.
You still would need to, like if I wanted to, I think probably what you're thinking right now is like when you run your tests, you never have to require files in classes to be able to talk to each other.
Yeah.
But actually the requirement is happening in your test. You've required all those files.
I see.
So if I, let's say in here, let's go ahead and just say like update equals status update.new. We passed it, add new status, sure. And this is just like part of our display right now. Let's jump out of here. And we haven't required that status update. If I jump into Pry and only require the photo, and then create a photo object. And if I tried saying photo.display, uninitialized constant status update. So I could have required it here, but if I want this class to be able to have access to the status update, then I do need to require it at the top. But you don't get this issue when in like your normal, in your projects that you've been creating, because you've been requiring them in your test.
Okay. Yeah, that's interesting to me. I guess I didn't realize that's what was happening. Yeah, I guess I don't know that I fully understand like why that is. So they just have to be required together somewhere and then they can talk to each other?
Yes. Yeah, so if you're running like for you, and I'm just going to put this in private now, but for you, when you're running your test, you say, let's say we had a test for photo. So Ruby test photo test. And so you run a file that looks like this. And in that photo test, at the very top of your photo test, you have a bunch of require statements. And the require statements that you have on there are requiring any class that the photo class is going to need access to. So since you're running it from here and it hits there, as soon as it hits that photo test class, it requires all of those files, and now it has access to all of that code. Just like here, as soon as I call any method off of a photo object, or even when I go to this photo class, I've already required this commentable module for this file. And so it's able to look over here to the module and have access to that now. But if I didn't require it, then it doesn't see that file. Doesn't know where to look for it.
I see. Okay. Yeah, that makes a little bit more sense.
Cool.
Thank you.
Yeah. Aiden?
Yeah, is there a way to require like all of the files in a directory?
Yeah, and I think that would almost come with a rake task. I think you, you would have to manually, actually, I'm going to take back the right task. You would still have to manually require them in like a pure Ruby application. And that might be something that you call out to in your runner file just to require everything. Could be something like that. As you get into other frameworks like the Rails framework, you'll hear a lot of like Rails magic happening. And there's a lot of communication amongst files with that framework. And so you don't have to get into this quite as much, this like manual requiring of files. So it kind of all depends on which framework you're working in. Right now, we're just working in raw Ruby, so we do have to require them.
Okay.
Any other questions? Sydney.
So I just want to make sure I'm understanding. So you're only using modules for classes that don't necessarily know about each other, but are using similar methods? Or like, why would you do that instead of chaining two? Like, you said, does that make sense?
Yeah, so you can chain, like, if you're chaining methods, that would mean that you have an attribute on an object that has access to that method. So if we, let's say we kept status update like this, and where we have all of these methods in here, if you wanted to reuse one of these without, I might be going down a different road than what you're asking, but
yeah.
What'd you say, Sydney?
No, I think this is what I'm asking. Yes.
Okay. So let's say like you didn't have those methods in the photo class and you're like, well, I have them over here in the status update class. What you would need in your photo class though is a status update object in order to even access this behavior. And even at that, this behavior would only be allowed to happen on status update objects. So we're saying that the behavior, these four methods over here, like the behavior that is produced by these four methods, is behavior that we want to be able to access, to get access by on a photo object, as well as a status update object. If we had access to, like in this case, if we had access to a status update object, we would only have access to these methods on that status update object. I would never be able to add a comment to photo, but I could only add a comment to status update.
Okay. And that makes sense. So that's what I was, yeah, okay. Because I was saying, so two classes that don't know about each other, they can share the same methods, like the same action. Okay.
Yes. Yep. As long as you have that module.
Okay.
Will?
Yeah, I think I'm just sort of thinking about this, but translating going to the display method you have here, they're not identical, but they're very similar.
Yeah.
They basically have to be identical for this to work. And I guess I'm thinking of our sports project where very similar type things, but we have different field names. So I suppose you just have to figure out a way to standardize the arguments, or
they don't need to be identical. So you could, let's see if we can go ahead and pull this up. So let's say for this commentable, let's go ahead and think of this like add comment method. And let's put it back into status update and photo. Let's say for the photo, whenever we added a comment, let's like tweak something in here. So let's say instead of it saying added this comment for a total of however many comments, we wanted it to say like added this comment to your photo for a total of this many comments, whereas over here it's like added this comment to your status update for a total of however many comments. So they're like a little different, right? Is that kind of where you're going at, Will?
yes, exactly.
Cool. So yeah, we could still use a module for this. You kind of have to weigh whether or not it's worth the little tweaks you would have to make in your module. Like how different is this? I would say if it's only slightly different, then I think a method in your module would be a great use for a module method for this. And for that, I would just have it take an additional argument. So it could be something like, and this, let's go ahead and pull this back up into your commentable. We can do this a few different ways. We could have something like if self, right? Self represents what you just called this on. If self.class is equal to photo, then display, or then like put something else in here, right? To, let's say, type of status update. You can have like some type of logic in here to help you change up what's going on in here. So in this case, class added on is going to be the difference here. We're saying like added this comment to, what does this say? To your photo, whereas this one says to your status update. So let's put this word your here. And this would be status update. So you could kind of like make it a little bit manageable through that there. You also, I think that's one way you could do it. It seems a little silly because it's just more code that you're putting in there. The other way that you could do it is you could pass in here whatever you wanted to get displayed. Like let's say this string photo came through and we call this class added on. Then we can just put it right in there. So you can make it more dynamic and a little bit more usable if you pass in more arguments to get added in whichever way you want to that method. Does that kind of answer your question, Will?
Yeah, that's perfect. Thank you.
Yeah. I think the other thing that we can kind of comment a little bit on for this is right now we have, let's say, let me go back to how this was. Okay. Let's say, this is how it was, right? Yes, okay. Let's say this is how we wanted it, and like maybe there's 5 other classes that use this method, and I want them to always look the same except for, let's say my photo class, I want the actual output of the add comment method to be completely different. Like the add comment method works completely different for the photo class, but everything else, every other class that includes that module, I want to use this method. There is kind of like a hierarchy that happens here. And if you think about scope, when we're looking for a method, it's going to look within that class first. And then if it can't find it within that class, even though the module is still included in the class, it'll then look into the module to be able to see if there's methods there. So if in here, let's just do this for just effect here, just quickly look at this. So let's say I wanted this to be very different. That's it being very different. And let's go ahead and get rid of this. So right now in my photo class, I have an add comment method. I also have an add comment method in my commentable module. We go ahead and drop into pry. We go ahead and require the photo, go ahead and create the photo object, and we say add comment. How does this work? This is what I got. So if something is like, if you want to include a module, but the method that is in your module is very different than what you want to be in that class, you can kind of override it by having a method in that class with the same name as the method that's in your module that you want to override.
Cool. And if we did something like that, would it be probably the best practice to like add a comment saying this is overriding the module or something like that so that somebody doesn't forget that? Or
I don't think so, because I think looking at your code, I would look here first before I look into a module.
Okay.
Curtis?
So kind of a two-part question. Can you like require a module in a module? And if you can, should you?
You can't, but you can have multiple modules included in your class. So you can have
Okay.
as many as you want in here, but your modules can't include other modules.
So like if you have a module, like I don't know, what I'm thinking is like I'm seeing a lot of like in our project, like methods that like search and format data and then methods that like work with that data. So like if you have like a module that does all the searching and formatting, can you like call methods from that module in another module?
Yes.
If they're both in the same class?
Yes, you can.
Okay.
Yep, as long as they're both included in that class. Good question. All right, let's go ahead. Let's take a little break. I need to charge my computer. Let's go ahead. Let's come back at 12. 10, 12. All right, go ahead, Cheryl.
Cool. So I started by creating the engine one. So I just copied and pasted the start and stop methods from both the Camry and Jeep, and then required at the top the lib.engine as well as included the engine. And then I ran into a little bit of a problem because I did require the lib on this one. So that was interesting. And so then, yeah, I ran the test to make sure that worked, and then created the air conditionable one, wrote the test, and then made sure they passed in both the Camry and Jeep after I made sure to require and include the air conditionable. And then when I did add the start method wait and then ran that, it failed because it didn't say chilly air anymore. This overrode it for the engine on. It overrode it and said wait instead of engine on.
Nice. Awesome. Thanks, Cheryl. You can keep your screen shared. Does anyone have any questions for Cheryl or specifically on the code that Cheryl is showing? Cheryl, you brought up this, you had mentioned it took you a little bit to get this like /lib in the require.
Yeah.
Does anyone have any ideas, and maybe you do too, Cheryl, why did you need that /lib in this one and not when we were doing it together as a group, when I was doing it with y'all? Joshua?
From my understanding, require is relative to where you are located when you run the file in the terminal. So since you have to first access the lib directory when you're running this, that's why.
Yeah, exactly.
That makes sense.
In our case, you're running your test, right, to be able to access these. Usually in an application, it would get run from your top level directory. And so that's why we tend to use require over require relative. So require always has it from like the top level directory where it's located. So that gives us instructions on how to find it in regards to that top level directory. So first go into the lib and then you can find those modules there. Whereas before we didn't have a lib folder, which is why we didn't need it. Any other questions? I know we didn't have any yet, but that's also fine. Great. Cheryl, thank you. You can go ahead and stop sharing your screen. And then in your Slack channel, I posted a few questions for you all in the thread of the breakout room activity. So if you take a look at that, one of the questions, I'm not sharing, am I? No, okay, that's fine. The first question that I had in there, and I'll take volunteers for this, you might not have gotten time to kind of look through this yet, but you can kind of think of them now as I ask the question. So the first one said, in the exercise you just did, so in that one that Cheryl just showed you all, why didn't I ask you to have a vehicle module that could hold engine and AC? methods, and what might the benefit of those being separated be? So why not just include all of these methods in one module for both of them? Why is it beneficial to kind of split those up into an air conditionable as well as an engine module? Garrett, what do you think?
I guess my guess would be it's similar to what we do with classes, and that like we want classes to be sort of single, like handle like one component of of a particular like project, for example. So like the turning on and off of the engine is sort of like a different functionality than turning on and off of the AC. So we might want to have like everything having to do with like turning on and off the AC. Maybe you have like turning up and down the AC. So like have all the AC functionality in that module, and then like have all the engine functionality in a different module so that they're separated.
Yeah, I like that. You mentioned like this, having all of that AC functionality in one module, and you kind of made that comparison to classes, right? When we talk about like what, I think a lot in your evals, I'll ask you all, okay, well, you created this class, like what was the purpose of it? And can you name the purpose of it? And so if we have a module that's a vehicle module, that could include a lot of different methods in it. So we're being a little bit more specific. And I think also when I think of functionality, I think of like features, and both Camry and Jeep, those are, I guess we do have them in different classes, but we could consider them both vehicles. And there might be vehicles that like a feature of that vehicle, one of the features is not air conditioned. So there's definitely cars out there, and I had one of them for a very, very long time that didn't have that feature. So maybe your car doesn't have that, right? And if we think about like those types of features that a class could have, you could have put that in one big module, but then we give access to all of those classes to a bunch of different methods that maybe those aren't features that we want that class to have. So it allows us to kind of divvy up functionality to different classes a little bit easier, and to limit that functionality amongst classes as well. Good. Second question was just kind of a review too, and we're kind of like coming to a close here. So if you all have more questions as we go through this, feel free to ask them. But the second question is, what is a module and how is it different than a class? So I'll take volunteers for that too. How would you explain what a module is, and how is it different from a class? Thanks, Hope.
Well, well, for one thing, modules don't get tests.
Yeah, so you test those module methods through the classes that are using those modules. Make sure that those methods that are stored in your module are accessible from your class that you're testing. Good. Yeah, go ahead, Hope.
And like you mentioned, they don't store state, so they can't do everything that a class can do, even if they're made kind of the same.
Mm-hmm. Great. So yeah, the structure of them, similar to a class, we use that keyword module instead of class, which just like you just said, Hope, the modules do not store state, and that's kind of the main difference, just behavior. Awesome. And then I guess for that last one, I'll just cover that last one there. So in order to be able to have access to a module, you need that require statement, and then you also need that include statement within your test, or sorry, within your class. Require statement, and then also the include statement within your class that you want to include it in. That's kind of the end of where I wanted to get for today. I know that we're finishing up about 9 minutes early, and I'm fine with that, but I want to open it up for questions if you all have any. I see a few hands pop up. Garrett, go ahead.
Yeah, so this is gonna sound like a really like maybe stupid question. And I'm not sure how to make it not sound that way. Basically, like, I guess the crux of the question is like, what's the point of doing this? And like, I know we've talked this whole class about the point of doing it, which is that like you get to separate out methods and you can use them between different classes. the alternative would be just creating the same method in two classes, which obviously is redundant as far as just like code goes. But as far as like the practicality of it, does doing this like actually speed up your like tests? Is it literally just it makes it a little more readable, a little prettier, and that's it? Or is there any sort of like, hey, this can like speed things up, or like
Yeah, I wouldn't say that it speeds up your code, right? Because you're adding a different place for your class to look for those methods. I would almost say, and I would have to benchmark things to see like how much it slows it down, but I would expect it to actually slow down. But the principle that we're trying to kind of solve and align with is that dry principle of not repeating yourself in classes. So when you have methods that are very, very similar, if not exact, that's when we would think about putting them into a module to get rid of that repetition in your code, like you had mentioned. And also, I mentioned before, modules are used for more things other than just shared functionality. It also helps with organization of your code, which you'll get into a little bit more in Mod 2, but if you all are interested in looking that up, it's called namespacing, is like the other main functionality that modules bring. And really what it is like an encapsulation to be able to organize similar code for different scenarios. So I can think of an example of like, this is just like a brief overview. Again, you can go into more later, but like if you had two different bike classes, and this is something that like ideally you shouldn't have two different bike classes, but you might get into code that has like multiple classes that are named the same thing. And so modules are a way to be able to like organize your code and say like, well, this bike class is for mountain bike and this bike class is for road bike. So it helps you kind of like organize and separate different types of classes. And so that's another feature of modules as well. Joshua?
Can you review the syntax of, so for that previous example we did, if we would have included the drive method as part of the module, like how do you write the conditionals to check the class that is utilizing the module?
Yeah, and I actually don't have, let me go ahead back to my example that I did with you all, because I don't have the code that Cheryl put up. So let me go into the one that we did together and I'll share my screen. So I'd say there's a few ways to do this. Honestly, I think you could check the class to be able to know what to output, but sometimes even within the class, it might be a different output. Like you might not always want it to be the same based off of a certain class condition or like what the class type is. So where is this? There you go. So let's say you wanted it to be a little bit different in here. I think how I would usually do it is, let's go ahead and put that add comment back in. If something was going to be a little bit different, then I would actually put it in as an argument into this method as like something that is variable. So currently I'm in the status update. In the commentable, this is how our add comment goes, and it just takes in one argument and it puts that argument into a string to get outputted. If we wanted something else to change in here, I would say that whatever calls that method would be responsible for passing in what it wants to be different. So in here, I could say something like, I think what we had the example of before was like what was added on, what object this comment was added on. So class coming from or something like that. So where is this coming from? You could probably rename this different, but adding that extra argument and having this method here be responsible for taking in an argument that allowed you to vary this output. So that way you could go ahead and put in here something else based off of what came in.
Okay, and the class method that you called, what was that again?
Yeah, and that one is so that was kind of what I was mentioning. Like, I don't necessarily use that very much, but what I was using here when I was saying self, is that kind of what you're referring to, Joshua?
Yeah.
Yeah, that's self. So let's go and put a pry in here really quick. And this does not take an argument yet, so it's going to error out. We'll just get rid of this for now. So if I go ahead and run this pry, and let's go ahead and jump into the photo, create a photo object, and say photo.add comment testing. Oh, you know what? I didn't even require it. Jeez, I hate when I do this. Oh, why is that
I
not
think
letting me?
it's accessing the add comment in the file
I
photo.
forgot that we had that. Thank you.
Mm-hmm.
One more time. This is why we write tests. Okay, there we go. So when I get here, if I take a look at what self is, self always refers to what you called this method on. So self, right now I call this method add comment on photo, this variable photo, which that variable photo stores a photo object. So when I call self, when I'm in that add comment method, that refers to what it got called on. So it returns to me like what it originally got called on. So here, if I said like self.class, that shows me it's a photo object. So
Okay.
I was thinking you could use that to help identify what you want to change within this method of add comment. That's one thing that could be helpful if you wanted different outputs based off of different classes.
Okay, thank you.
Yeah. I know there was a few others. Mike?
That was a question that got answered from somebody else.
Okay, cool. Curtis?
Is utilizing a module, like, is that something better to like plan on at the beginning of a project, or is that more of like a refactor thing? Like,
I would consider it more of a refactor.
Okay.
Yeah, make it as you go. When you start noticing that there's some repetition in your methods, that's when I would think, okay, let me just go ahead and make a module. But I usually don't plan ahead for those. It's just something that comes as I get through the project. Good question. Great, Ellen. All right, it's 11 o'clock. I'll let you go, and I think we have one-on-ones. If you have not signed up for a one-on-one and you do want one, we wanted those to be signed up for by yesterday, but if you really wanted to and you were not able to get your name in on time, just Slack all three of us and we can get you signed up for one possibly tomorrow. But they're non-technical check-ins just to see how you're doing and just to chat with you all. So if you do want one, you weren't able to sign up for one, just Slack us and we can try and get you on the schedule for tomorrow. Other than that, if you did sign up for one on Tuesday, today, then you can take a look at the calendar and the times are in that for when your check-in is. All right, see y'all later.
Thank you.
Yes, goodbye.
Thanks, Meg.
You're welcome.